remember the element that I mentioned? Garage door, pasarela, bautroste, 7 elements, no? It's a lot. I want to calculate the capacity of my new system, because I am going to install a new motor, a new valve body with 7 outputs, no one output like this, not 2, not 3, 7 or 10, yeah? Different actuators internally to send the fluid for that unit, 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 and also the solenoids per each equipment. All right. The number one is I am going to add it all the equipment. Okay, I have a pasarela. I check in the actual label of the pasarela
the voltage.
I'm going to copy how much is the pressure for that system. Is 120 psi, and the flow of the pump is 1.5 gallons per minute. Voltage no, because after that I am going to take a decision. I'm going to replace all of those are DC units. I'm going to replace all of those 7 DC units for one central AC unit with more capacity. Okay, I have the garage door. The garage door is 150 psi and is 0.7 gallons per minute. And I have the other one, and I have the other one, and at the end I am going to
total it out.
All right, is for example 800 psi, and I have 5 gallons per minute. For example, it's an example. I added, bam, 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 bam. And after that, we are going to use the first formula. The first formula says what? Horsepower is equal to the pressure in psi
times
the gallons per minute
divided by 1714.
1714 is a constant to convert units.
Yeah.
No?
Yes.
Okay. According with this, I have a 800
times 5
times 5
divided by
1714. How much is that, Doctor?
4,000 divided by 1714.
How much is that? Quickly.
2.3337.
3.
Horsepower. No?
Correct.
2.38 horsepower. This is a 2 horsepower engine. True is 2 and a quarter horsepower. This is common, no? That motor is common. And okay, can I convert that horsepower in kilowatts? You remember?
Yes.
Yeah.
1 horsepower is equivalent to 746 watts. How much is 2.38? 2.38 times
746.
1,000.
Excuse me?
1,775
1.78 kilo watts. All right. This is the motor that I need.
Do you not add 20% to that? Or?
Yeah. You added 2 kilowatts. Okay, I need a motor, 2 kilowatts, to support all of those elements. Nice, no? What motor is better? AC or DC? AC. AC 3-phase. Because I want
reversible.
reversible. And I am going to use contactors, you remember?
Yep.
To reverse the rotation. Yeah, right now you feel like engineers, my friend. You are familiarized. Now you enter in the engine room and you say, oh, they use AC motor. Where are the contactors? Oh, look at the contactors. They use DC motors. They have a solenoid control box. Oh, look at no, they don't have, they have a couple of relays, but it's the same for the reverse rotation, no? Okay? Okay. Right now we are going to do in two directions the explanation. We are going to go to the board and I am going to explain the procedure to integrate everything and after that we return to the board and we explain the procedure. Okay, guys? Okay, right now I know that I need a pump. I need a pump with
5 gallons.
5 gallons
or more.
or a little more if it's possible, and minimum
800
800 psi. This is the pump that I need. And I need a motor of 2 kilowatts. Those are the minimum characteristics. I have the capacity of the motor and the capacity of the pump. Always, always, always when you select a pump, when you call, hey, my friend, I need a pump. They ask to you, how many gallons and how many psi? That's it. Those are the 2 questions for the dimension of the pump. And you say, I need 5 gallons. Okay. And how many psi? 800. All right. Okay. Probably this pump is good, and they have different options for you. The option is if the pump is vertical, if the pump is horizontal, how can you fix it, the pump in the frame that you have? No, I need a vertical pump because the shaft, okay, you need that pump. No, I need horizontal, and I need with aluminum case because the environment is highly corrosive. Okay, because I have another cheaper, but it's regular steel, the case. No, for the engine room, I prefer the aluminum casing. You know, that's your decision according with the corrosion and the materials. Okay, now we are going to go to the board, and we are going to connect everything together. You like it? Okay, guys, you remember that we said with Danny at the beginning that the hydraulic circuits are pretty similar or basically exactly the same like electrical circuits? Yeah, okay. And you remember that we said that instead of the battery or the source of power, you have in hydraulics, instead of the battery, you have what?
Pressure or a pump.
You have the motor. The motor supply power, no? And instead of the switches, you have
Yeah,
you have
Body of valves.
the body of valve with the solenoid or with the handles. This is a manual switch,
Manual, yeah.
and the solenoid servo valve is like a relay,
Signal. Yeah.
with a remote signal. It's exactly the same. And you remember in a circuit, especially for example, when Danny and me, we explained the procedure to connect the gauge in the dashboard, you remember?
Yep.
The oil pressure gauge, the temperature gauge, what was our recommendation when you connect all of those gauges?
In parallel.
Ignition.
No, I didn't see it.
Create an ignition bus bar,
Oh,
and after that connect all the gauge to connect everything
In parallel.
in parallel.
Because if it's in series,
this one
then one-
is broken, the other ones are running. No? It's exactly the same. We have a positive bus bar, the supply manifold, and we have a negative bus bar, the red one, the return. Oh, positive bus bar, negative bus bar.
So positive and negative pressure.
It's positive and negative, exactly the same.
Okay.
And in the electricity, we have the voltmeter to check pressure.
Pressure.
You have
Volts,
pressure.
yeah.
You have pressure gauge, and we have the ammeter to check what?
Amps or intensity.
The flow of amps. We have the flow meter. The flow meter in series, and the the ammeter or flow meter in series, and the voltmeter or pressure gauge in parallel. You like it? It's
Yeah.
exactly the same. And you remember with the potentiometer, you increase or decrease the output voltage in DC. You remember?
Right.
Yeah.
With potentiometer, you increase the output voltage 12, 11, 6, 7, 4, 3, 2, 1 volt. You remember? With the potentiometer. We have potentiometer for more output pressure, less output pressure. Exactly the same.
And what appliances would? And what
Oh,
appliances?
this is a relief valve. Because I have here in the design that we calculate how much is the output pressure? 800 psi. We have 800 psi. But for the actuator of the pasarela, I need only 200 psi.
Oh, okay.
Or I buy one of these with the input 1,800 and the output fixed the output 400.
Got you.
Or the output 500, or the output 300. Yeah,
So each individual piece of equipment has its own output where you can.
Doesn't
decide
matter how
want
much
to
you
come out.
introduce, the output is 300.
But each equipment has its own output, right? Where you can manage the flow. Each, like the Passerella, has its own hookup where you can
This
manage
is only
flow.
the pressure.
Okay, but each piece of equipment
Yeah.
though has that, correct?
Correct.
Okay,
It's for each one.
gotcha.
Yes, this is a good question. Because I decide in that design, integrate Passerella, the davit, the crane, the garage door, bow thruster, steam thrust. I integrate 7, no?
Right.
And each one have different
Pressure.
pressure and different flow.
Yeah.
Yeah.
Ah, can I do that with only one body of valves?
No.
No.
Yes.
Oh, one body valve. But
Yeah,
you need,
but
need
you have different
outputs.
you have different
outputs.
pressure regulators.
Right.
Ah, I have a pressure regulator. The output is 150 for the Passerella.
Right.
The output is 250 for the garage door.
voltage
The-
regulator.
yeah, like the voltage regulator. I have one voltage regulator per each equipment. You like it? Okay, I am going to bring that one from the supply manifold into the input. Look, the manifold have input and output, or input and output, doesn't matter.
Okay.
And this is the control. Okay, look, input here. And what about the output?
Other side.
Other side
Output, where should be connected?
to release.
To the output.
To the return and into the
okay.
tank. Okay, I have another hose marked. Yellow, red, yellow, red. You see? Okay, and this is the return. And this is the return. And the return is connected to the
To the
return
negative.
manifold or negative bus bar. Okay, now I am ready to connect the actuator. I am ready to connect the actuator. Okay, one of those terminals to one part of the actuator and the other one in the bottom to the other part of the actuator. You know? Okay, this one for and the other one
So yeah, so we're running them both at the same time, but one in, one out.
and this one
Oh, okay.
here. Ready? Bow thruster. Okay. What do you think that is the idea to connect the flow meter? The flow meter should be connected how? In series or parallel?
In series.
In series, like the on meter. No? Okay. I am going to interrupt. I am going to interrupt one of the lines here, and after that I continue from here into here. Yes or no?
Yes.
I interrupt one line. And now I can see it's 4 gallons. You see? You see?
More guidance. Yeah.
You like it?
But now,
What about the PSI on?
Oh, the
That's okay.
PSI, the scale is too big. That one
Very
only
little PSI.
only use 60 PSI.
Oh.
For that reason, that one starts in 100. You can replace the gauge for other one with a less scale. But that's the process.
That's a motor, sir?